Hi there, Pre-Calc students. It's time for another online lesson. This one, 2-5 Determinants and Inverses of Matrices. Now, as you look at all these pictures of these items on this screen here, what do they all have in common? Well, what I'm trying to get at here is that these are all items that I'm going to use this fancy word, and it is antiquated. So it's kind of like the word antique in a sense, that each of these items could be considered antiques. They still work, they're still useful in some regard, but they're out of date with what we now know. And the topics we're going to talk about today will show you those, but we'll show you some modern ways of thinking about them that I think you'll be able to enjoy. So all matrices in this lesson that we're talking about here, we say are square. And by a square matrix, as you might guess, it has the same number of rows and columns. So a 2x2 matrix, 3x3, on and on like that. So the terms you talk about here in this lesson apply to only square matrices. One item here now we're going to look at first is something called a determinant. It's a value associated with each matrix. Again, its importance now is not so significant as it once was because of the technology that we now possess. But here's how we calculate determinants. Fairly easy if you think of your cross-multiplying that you learned about in middle school or even elementary. That's in a sense how determinants are calculated. So we start in the upper left-hand corner, we multiply these two kitty corner items. So in this case, -2 times -1 will give you +2. And then we're also going to multiply the other kitty corner entries, which is 4 times 3, which is 12. And we simply subtract those two values. And so 2 minus 12, so the value for this determinant is -10. I'm not going to show you a slide of this, but you may want to look at your matrix menu that we've been using this chapter and see if you can find determinant in there. There's a nice way of calculating that, and you can verify that that works for this particular case. Another couple key items we want to talk about is the identity matrix. The identity matrix, as you can see, in this case it's a 2x2 matrix, but we could have an identity matrix that's a 3x3 or a 4x4. The key thing about the identity matrix is the ones in this main diagonal here. So that's what that involves. And just like you've learned in your past mathematical lives about additive identity and multiplicative identity, the key thing about an identity matrix is when you multiply a matrix by the identity matrix, you get the same thing. And we can illustrate that a little bit here with the inverse matrix. And an inverse matrix, kind of like the word regular inverse, is when you multiply it by the original matrix, you get this identity matrix. So just a quick example here, and I've showed you on the calculator how to do that. Let's say I have this particular matrix here, a 2x2. Here's what the screenshot should look like when you enter this in your calculator, so you may want to do that. 2x2, of course, 3, -5 for the top row, -7, 11 on the bottom. And here is the inverse matrix of that. All I'm doing is just taking that A and then the -1 power and actually get those values. But here's a significant thing. Notice on this last screenshot, when I multiply the inverse by the original matrix, look what I get. I get that identity matrix. So that's fairly significant idea. This would just be like if you multiplied a number by its reciprocal, you'd expect to get 1. So with matrices, when we multiply an original matrix by its inverse, we don't get 1, but we get something akin to that, the identity matrix. This primarily is in solving systems of equations. You might recall our very first lesson we showed the various ways of solving systems like graphing and elimination and substitution. And then we also had matrices on there. Here's where we want to learn how to solve a system using matrices. although we did kind of do that with the 3x3 matrices, if you remember that. But anyway, let's try it with this simple system, 2x2 system here, 4x minus 2y equals 16 and x plus 6y equals 17. I'm going to enter what I would call the coefficient matrix in my calculator. And that's just a 2x2 matrix that has the coefficients in there. So there we go right there. And matrix B then I'm going to call my answer matrix, which is going to be a 2x1. I enter that right here. Now a nice way to get the answers, and you might remember how we did this on the board, how we kind of divided by the variable, and dividing is the same as multiplying by the inverse. And so really that's what I'm doing here. I'm taking the inverse of this matrix, multiplying it by the second one, and sure enough I get my answers. So the idea here when I do this is that my answer is x equals 5 and y equals 2. In other words, the ordered pair 5, 2 is the solution for this matrix. Now this works especially well when we have some real nasty numbers that are a solution to a system where it might be difficult to find them by graphing or by the other algebraic means. So solving a system using matrices is just another tool in our arsenal for solving these systems of equations. So that's about it for this lesson. Pretty easy, I think. If you look through the lesson, there are a lot of nasty things in there involving determinants to find inverses. Again, that's an antiquated approach, still useful, but something that we're going to gloss over here a bit. So the most significant things we have in our lesson here, and we'll work on this in class tomorrow and the rest of the week. Farewell.